Okay, welcome back to the Lewis Structures with your TA, Joseph Wilson. We are going to turn up the jazz and have a good old time finishing up these challenge problems. Cool. HOBR. Okay. What's the central atom? I guess I don't know. Let's just say that oxygen is. And if oxygen forms a sensible Lewis structure, I guess that's the central atom. How about that? How about that logic? Okay, hydrogen has 1, oxygen has 6, which I'm going to draw like that for, whatever reason. Bromine has 7. And then we connect the dots. How about that? That's how it works. Okay. And I checked to see that's okay. It is okay. So the base shape on oxygen is trig. No. Tetrahedral, sorry. Tetrahedral. The shape of oxygen is the shape of water, which is bent. There's no charges on any of them. Is it polar? Well, what does it look like? This Lewis structure shows the electrons, but it doesn't really show what it looks like. That's why you draw it like that. And this is fun. This, guess which is more electronegative, oxygen or bromine? Well, oxygen is more electronegative than hydrogen, and oxygen is more electronegative than bromine, which, I guess you would look up on a table. So there's a dipole moment, which you can clearly tell, and it is polar. And the hybridization is sp3, a common one. Okay, ClNO2. Okay, let's just say I don't know what the central atom is again. Let's just throw out Cl. I'm saying Cl is the central atom. Now I'm going to see if it makes a sensible portrait. Nitrogen has 3. Nitrogen has 5 electrons. Don't know where to put those. Oxygen has 6. Oxygen has 6. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. Wait, is that correct? Yeah. We connect the dots. And then these electrons I indicate are drawing. Okay, is this a real thing? I actually do not know. But we can use our skills to we'll look on the nitrogen. Nitrogen has an expanded octet which cannot be a thing. Chlorine has a charge of +1, right? Because is that right? Nitrogen has a charge of, nitrogen wants 5. It has 1, 2, 3, 4, 5, 6, 7. It has a charge of -2. Chlorine has a charge of, it has 7. It wants 7. It has 1, 2, 3, 4, 5 +2. Do you guys see that this is This is definitely not a thing. It's definitely not going to happen. So we didn't connect the dots correctly. Is there a way to connect these dots in a sensible way? I kind of don't think there is. Okay. So I guess chlorine's not the central atom, which, shocker. Let's say nitrogen is. Okay, it's kind of sandwiched in between that. Okay. So, let's draw all the electrons. Nitrogen has 5. 1, 2, 3, 4, 5. Oxygen has 6. Okay, let's connect the dots. Okay, this has all the electrons are accounted for. We ask ourselves something like, is the octet rule followed? And then we observe that is not. Nitrogen only has 6 electrons. So let's move these electrons, or these electrons maybe. You know what? We're just going to erase them and draw them here. Okay, is this correct? Nitrogen has a +1 charge because it wants 5. It has 4 from the 4 single bonds. Oxygen wants 6. It has 6 lone pair electrons and 1 extra from the covalent bond, so it's -1. So the total charge is 0. However, this is incorrect. This does not give you full points on the test, because you need to find a way to imply that the negative charge on oxygen is shared between the other oxygen as well. And we do that by resonance. What joy, what great joy. And this is what I draw when I'm drawing a resonance structure. I'm not going to draw all the lone pairs again. I'm just going to draw super simple. But I'm definitely 100% going to draw the charge there, because that is acceptable nomenclature for leaving out all the lone pairs, is if you make sure you draw all the charges wherever they are. Okay, the shape on nitrogen is trigonal planar. There's 3 domains. The base shape is that. The molecular shape is that. The is it polar? This is a good one. There's a dipole there, and a dipole there, and a dipole there. Well, I don't think these add up to 0 because they're different. Oxygen is a little more electronegative than chlorine, but not that much. So it's tricky to tell exactly where the dipole is, but let's just say it's polar. That's a fun one. And if you don't know what to write on the test, just say the polarity is the sum of the dipoles. These are the dipoles. And you would say, because I'm not going to do some crazy calculation, that's all I can give you right now. Okay, so no complaining. So the hybridization on nitrogen is sp2, because it is trigonal planar. These always imply each other. N2O, that sounds like it's probably pretty easy compared to what we've been talking about. Okay, so what's the central atom? I don't know. Maybe oxygen is. 1, 2, 3, 4, 5, 6. Oxygen is 6. Nitrogen is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's connect the dots and see what we got. Okay, you can see the nitrogen doesn't have, nitrogen has, does not have its lone pair being filled, and the only way for it to be filled is for these electrons to come down off the oxygen like that and form a double bond between each of these, and say, well, is the octet rule being filled? It sure is. There's no expanded octet. These are all first row elements. But then you ask yourself, what's the formal charge of all this? Nitrogen wants 5. It has 1, 2, 3, 4, 5, 6, -1. -1 on the other nitrogen. And what's the formal charge on oxygen? It wants 6. It has 4 from each single bond. So it's +2. And you have drawn a structure with a +2 charge on an oxygen next to a negative charges on other atoms, which are less electronegative. So this is just, you had to say to yourself, yeah, the octet rule is full, but it's total garbage. Because what I know about chemistry, about the charges and electronegativity. So you erase it all. So I guess let's see if we get a sensible thing from nitrogen as the central atom. That's not. Okay, oxygen has 6. Nitrogen has 5. 1. Let's draw, oh, I don't know, 1, 2, 3, 4, 5. Let's draw 1, 2, 3, 4, 5. Let's just kind of see what happens. Let's connect the dots. And these electrons. And now we ask ourselves, what's this? Let's draw the formal charge and everything. Oxygen wants 6. It has 6 lone pairs and 1 covalent. -1. Nitrogen wants 5. It has 4 on the central one. +1. This nitrogen has 5 and it wants 5. So it's overall neutral, so it's valid. The electrons check up, and this is way more reasonable than saying that there's a +2 plus charge on oxygen. Therefore, you know that is what you want to write on your test. Okay, so this nitrogen is the central atom. It is linear. The shape is also linear. Is it polar? It is polar. There's a dipole going that way, and there's no force between these nitrogens. How about that? Okay. Okay. And it is sp hybridized. Okay, SCO. This is really fun. I wonder what the central atom is. I'm just going to guess what I automatically know is the central atom because I am tired. But, carbon is always a very good guess for what the central atom is. Sulfur has 6 electrons, which I'm going to draw like that. Carbon has 4 electrons, which I'm going to draw like that. Oxygen has 6 electrons, which I'm going to draw like that. And then we play a fun game called Connect the Dots. Okay. Now we ask ourselves, is this reasonable? What's the formal charge? Carbon, it doesn't even follow the octet rule, so we can't even get to that place yet. So let's make sure everything is following the octet rule. That should be. So what we're going to do, these electrons are there, come down there. These electrons go right there. They're double bonds. Okay, sulfur on the left, it wants 6. It has 6. Carbon has a 0 formal charge as well. So does oxygen. That seems very reasonable to me. So the shape is linear. The molecular shape is linear. Is it polar? Okay. Well, carbon has a dipole to oxygen. And it also has a dipole of the sulfur. And you need to know that oxygen this dipole is bigger than that dipole. So the overall dipole is that. It is polar. And you need to tell what the direction of the polarity is. It is polar, and the hybridization is sp. Okay, we're almost done. IBR. IBR. Interesting. Oh, what? One, two, three, four, five, six, seven. 1, 2, 3, 4, 5, 6, 7. Huh. Draw the line. Connect the dots. Where does the negative, where does the extra electron go? Hello? One moment. I copied this down wrong. I must have. IBR2. There we go. So, I don't know. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Iodine. How many are we going to draw on iodine? Let's make sure we have the right number of electrons. It's a -1 charge. There is 7 plus 7 plus 7 plus 1 electrons, which I refer to as 22 electrons. Iodine. Let's put that extra one on iodine. So 1, 2, 3, 4, 5, 6, and then 7, 8, because it has 8. And now we play connect the dots. And is that valid? Iodine doesn't follow the octet rule, but it doesn't really have to, because it is a grown element. That's valid. That is it. No resonance structures. That's just it. Okay, the base shape is trigonal by pyramidal. Okay, the shape of the molecule is linear. Let's look what that looks like. Lone pair there, lone pair there, lone pair there. Bromine there, bromine there. Iodine, of course, is the central atom. It's right here. That's what it looks like. Linear. So is it polar? It is not polar. It has polar bonds, but they cancel each other out. Okay, and the hybridization. Oh, this is a fun one. sp3d. Because there's 5 things. sp, p, d. 1, 2, 3, 4, 5. Okay. SCN. Very cool. Cool stuff. Minus. Brackets. Yeah, put brackets over the ions, I guess. Or what I think is much better, which I keep on forgetting to do, but I would not forget to do on the test, is put the formal charge of every thing you encounter. That's not 0. Iodine, right here, it wants 7. It has 6, all to its own from the lone pairs, and 2 more, so it has 8, so the formal charge is -1. That's what I would draw. So let's draw these. Carbon has 4. Sulfur has 6. Nitrogen has 5. And then, oh, there's another one. We can put that there. And now I guess I didn't really connect the dots as well as I thought I was going to do. But no matter. There's a bond there. And a bond there. Bond there. And a bond there. Which, of course, we will redraw. How about that? It is linear at the central carbon. The molecular shape is also linear. It is polar because it's unbalanced, and sp hybridized. Those are the two dipoles. I don't know. Maybe nitrogen. I think probably nitrogen is probably more electronegative, but you wouldn't need to know that unless we specifically told you. But either way, you know that they're unbalanced and that they're linear. Okay, ONCl. Let's say that nitrogen is the central atom, which, of course, I don't actually know, but I'm hopeful. 1, 2, 3, 4, 5. Nitrogen. Chlorine has 7. So this is my fun game of connect the dots. I don't know if it's going to work out for me this time. Let's draw these as a pair there and draw that pair. Okay, nitrogen doesn't follow the octet rule. But how about these electrons from oxygen come down and form a double bond. Okay. Now, the formal charge on all those species is 0. And I think that's our molecule. Which I feel like we did before, but whatever. The shape, the base shape is trig planar. It is bent, the molecular shape, but not like water. It's a different kind of bent. Is it polar? Well, we need to draw what it actually looks like, a better representation of what it looks like. And these are both polar bonds. Well, I guess it's polar, as we can see. And it is sp2 hybridized because it is trigonoplanar, the base shape, so therefore it is sp2 hybridized. Those directly imply each other. Oh, look, the last one. Sulfur that's not the name of it because it's an anion. Okay, so we play our fun game of connect the dots. Fluorine has 7. 7 there. Sulfur, okay, that's 6. 1, 2, 3, 4, 5, 6. Oh no, where does the other electron go? What? And then there's a left. See, this is why you always count the electrons. Where does the other electron go? I don't know. I think I wrote down the question wrong. You know, there's definitely not a negative charge. I state it. So that's it. That's the molecule, not the ion. The shape is tetrahedral, the base shape. The molecular shape is bent like water. And is it polar? Well, we need to draw it in a way that specifies the shape. And you can see it is polar. Wow, cool. And polar. And what's the other thing? sp3 hybridized tetrahedral. Wow, what a great way to spend your Friday night, am I right? How satisfying. Let's you can hop off now, but I'm going to make sure all of the formal charges are there. Okay. Looks good, looks good. Okay. Yep, that's it. Well, thanks for watching. Tune in next time.